Welcome to another mechanics lesson. Here we continue the discussion on work done on an inclined plane. Let's look at this problem. A 20 kilogram box is pulled up a rough incline that makes an angle of 30 degrees with the horizontal. The applied force F is equal to 150 Newton acts parallel to the incline. The coefficient of kinetic friction between the box and the incline is mu is equal to 0.25. The box moves 8 meters along the incline. A. Calculate the work done by the applied force. B. Calculate the work done by gravity, that's a parallel component. C. Calculate the work done by friction. And D. Determine the work done on the box. Now, before we begin, recall the following. The parallel force F parallel is equal to mg sine theta. The perpendicular force F perpendicular is equal to mg cos theta. The normal force F sub uppercase N is equal to mg cos theta. It is the same magnitude as the perpendicular force. They just the same size and act in opposite directions in these scenarios. The friction force F of FF is equal to mu F sub N. We're given that the applied force is equal to 150 newtons, that theta is equal to 30 degrees, mu is equal to 0.25, and D is equal to 8 meters. Also, we have information up here that the mass of the box M is equal to 20 kilograms, all right, 20 kilograms. Now, if we were to draw a free body diagram of the above scenario, you would see that there is a box and the applied force is pushing upwards. The force of friction goes against the applied force in the direction of motion. That is pulling it down the incline. Also, the parallel force is working down the incline in this case. Now the normal force is pulling the box upwards into the air, and the opposites of that which is your perpendicular force pulling it down into the ground. Now, let's look at some calculations. You want to find the work done by the applied force. We denoted W sub case A, that's equal to force times the displacement. So the applied force rather is 150 newtons, and the displacement is 8, so 150 times 8, that gives you 1,200 rather joules. Part B, the work done by the parallel force. You first find the force, which is mg sine theta. So I'll be substituting m for 20g, 9.8. We're assuming it's 9.8 meters per second squared, and times the sine of 30 degrees, and that will give you 98 newtons. To find the work, you multiply the force times distance as usual. So that's the work done by the parallel force is equal to the parallel force times the displacement is equal to 98 times 8, and that will give you a total of 784 joules. Now notice here that the parallel force was opposite the direction of movement, so the sign on it would be negative. The SIGN on it would be negative. Now, part C, we're trying to find the work done by friction. So first we look at what the normal force is. So that's mg cos theta. Let's plug in numbers. That's 20 times 9.8 times the cosine of 30. And that gives you 169.7. Unit is newtons. For the friction force, is equal to nu times Fn, and so we calculated Fn already, and mu we're given to be 0.25. So 0.25 times 169.7 equals 42.4 newtons. So that's the friction force. And then the work done by friction would be force times distance, friction force times the displacement, which is going to be equal to 42.4, where your force times the displacement, which is 8. Multiplying them together gives 339.2 joules. Again, the sign of this would be negative since it is going against the direction of motion of the object. All right, finally, net work is going to be the work done by the positive component, which is applied force, minus the work done by the negative components, which would be the work by the parallel force and work by the force of friction. And so then if we want to distribute through the brackets or add them first and then subtract, not a problem, we get the same answer. So work done by applied force, that's 1,200 minus the work done by the parallel force, which is 784. So subtract 1,200, subtract 784, and then from that, if you distribute minus sign through, we're going to also subtract 339.2. So your final answer is 76.8 joules. Now that we're here, let's try this one. It reads a 15 kg crate is pulled up a rough incline that makes an angle of 25 degrees with the horizontal. The applied force F is 120 newtons and acts parallel to the incline. The coefficient of kinetic friction between the crate and the incline is mu k is equal to 0.2. The crate moves 6 meters along the incline. A, calculate the work done by the applied force. B, calculate the work done by gravity. That's a parallel force. And C, calculate the work done by friction. And then D, determine the net work done on the crate. Thank you.